Guys, so the parts have finally arrived and I'm very excited to start doing this project. Finally, we were able to complete the structure of the car, and let me show you. So these are the two chassis of the car which have been connected with the help of the nuts and the screws, and the four motors have also been fixed, and the four wheels are also fixed into the car now. And so this part is complete, the structure is complete. Now we'll move on to the next part. Okay, so we have soldered the wires to the four DC motors, and now let me show you some more parts. So if you see closely, this is the Arduino Uno, and the entire program that will run the car will be stored here, and you can call it as the brain of the car. So this is the Arduino Uno, and then here we have a L293 motor driver shield. So this will help us to run the motors of the car. So first let me connect this motor driver shield with the Arduino Uno. Have to be very careful because these pins are very delicate and they may break. So I have connected the driver shield to the Arduino Uno, and now I will connect it to the structure of the car with the help of a double-sided tape. So let me see the direction. Okay. So there you go. So now the motor driver shield, which is connected to the Arduino Uno, has been fixed to the structure of the car. So now next we will connect these wires to this motor driver shield.
Now I will explain the components of the circuit. Here we have a HC05 Bluetooth module. This module has 4 connections. One connection is to the ground at 0 volts, one is to the VCC at 5 volts, and there is a transmitter TX and a receiver RX. The transmitter TX of the Bluetooth module is connected to the receiver RX of the Arduino board at the 0th pin, and the receiver RX of the Bluetooth module is connected to the transmitter TX of the Arduino board at pin 1. We have made all the connections in the circuit using jumper wires. Here we have 2 rechargeable batteries and a switch. In the real circuit, this is the real circuit, we have a L293D motor driver shield, and this is the HC05 Bluetooth module. These are the batteries, this is the switch, and these are all the connections using jumper wires.
Now I am going to explain the code. Initially we have included the header file adafruitmotor.h. Then we have initialized the 4 motors 1, 2, 3, 4. Then we have set the PWM pulse width modulation to 64 kHz. Then we have initialized to variable state and speed and assigned the default value of 130 to it. In the void setup function, we have set the default speed of each motor to 130. Serial.begin 9600 implies that the exchange of data between the Arduino and a computer will take place at the speed of 9600 bits per second. Then we have given a delay of 500 milliseconds. Then we come to the void loop function. When the Bluetooth module is switched on, serial.available becomes 1 and the program proceeds. State equal to serial.read. We take the value of the state using the mobile app that we are using. When state is greater than 10, the speed is set to the state, which in turn changes the speed of the motor, as you can see here. And finally, we give a delay of 80 milliseconds.
For key control command, the state 1 is for forward, the state 2 is for backward, the state 3 is for turn left, and the state 4 is for turn right, and state 5 is for stop. For the voice control command, state 6 is for turn left, the state 7 is for turn right. If the forward button is pressed, all the motors rotate in a forward direction. If the backward button is pressed, all the motors rotate in a backward direction. If the right button is pressed, motor 1 and 2 run in a forward direction, and motor 3 and 4 rotate in a backward direction. If the turn left button is pressed, motor 1 and 2 rotate in a backward direction and motor 3 and 4 rotate in a forward direction. If the stop button is pressed, all the motors are released and the car is stopped. Then for the Bluetooth voice control command, turn left is for state 6. So after reaching the state 6, there is a delay of 400 milliseconds, after which state 5 is reached, so that the motor does not go on rotating endlessly.
Go forward. Turn left. Go backward. Go forward. Stop. Now we'll increase the speed. You can see the speed has been increased now. Now again we'll decrease the speed.